Hexagonal architecture, also known as ports and adapters architecture, was designed by Alistair Cockburn. It focuses on the decoupling of the application's core logic from external factors such as databases, user interfaces, and other services. This architecture emphasizes the separation of concerns by isolating the application's domain logic, the part that encodes business rules, from its interactions with the surrounding environment. Now, some of the components of hexagonal architecture include first, the domain model, central to the application containing the business logic and data it represents the state and behavior of the business scenarios. Ports, interfaces that define the points of interaction between the application and the outside world. There are two types of ports: primary driving ports. These are used by the outside world to send commands to the application. Example, a REST API. Then there is secondary driven ports. These are used by application to communicate with external systems or services. Example, a database. Next is the adapters. Now, implementations that connect the ports to the actual external technologies or services. They translate between the format and protocols used by the external resources and the domain model. We have the primary adapters, which handle input into the application. Example, web controllers. And then we have the secondary adapters, which handle output from the application to the external systems. Example, database repositories. This is the entire architecture for an hexagonal architecture or ports and adapter architecture. Now, what are the benefits? Benefits include flexibility and maintainability. By decoupling the core logic from external components, the application becomes easier to maintain and evolve. Interchangeability of components. Adapters can be easily swapped out for alternative implementations without affecting the core domain logic. We have isolation of the domain logic. Simplifies testing and development as the business logic can be tested independently of the external elements. There comes the drawbacks, complexity. The architecture can be overkill for simple applications where such a high degree of decoupling is not necessary. The learning curve, developers might find the architecture challenging to understand and implement correctly, particularly if they are not familiar with its principles. Let's look at an example. Imagine a web application for booking flights, which has the domain model, which contains classes and methods that model flights, reservations, and customer interactions. We have primary port, which is a REST API through which users interact with the application to search for flights and book them. We have secondary port, which interfaces for accessing a database to store and retrieve booking and user details. We have primary adapters, a web controller that processes HTTP requests from users and invokes the appropriate domain services. And then we have the secondary adapter, a database repository implementation that handles all database operations required by the domain services. Now let's look at a real world analogy. Think of hexagonal architecture like a universal power adapter that allows an electronic device, let's say the domain model, to be charged from different types of power outlets, which are the external systems, around the world without needing to change the internal components of the device. The popular use cases include enterprise applications, where business logic needs to remain stable while technologies around it evolve. We have financial systems where the core processing must remain isolated from external interfaces like banking networks and payment gateways. We have e-commerce platforms managing core functionality such as order processing independently from user interfaces and payment systems. Hexagonal architecture is particularly useful in complex applications where the business rules are stable and longevity is desired. But external interfaces may change due to technology shifts or new integrations. This architecture style ensures that the application's core logic remains untouched by changes in the external layers, facilitating easier updates and adaptations. If you have any questions on hexagonal architecture, please leave me in the comments.